Alright, hello everybody out there in YouTube land. This is Kieno Thomas from Kieno Training Systems, and if you saw a previous video that I did, it was one addressing the fact that on all the military aptitude testing, the mechanical comprehension portion of it has been transitioning from more of gear, pulley type questions and leverage questions. You will see a few of those, but they've been leaning in the area of physics. So I am making a video series to address a lot of the concepts that you will find on the test that are concerning physics, and you will not find a lot of these you won't find a lot of these topics in the test preparation books. I'm not going to name the test preparation books, but if you're out there and you're buying these manuals, and you know, the math portion is good, the word knowledge, the mechanical is just kind of lacking in a lot of these books that I see. And I'm like a Barnes and Noble head. I go into these stores, these bookstores all the time, and I look through these manuals and I'm like, wow. And so basically what I'm doing is making a video to prepare you for some of the things that you won't find in the test prep books that you'll definitely, probably, more than likely see. Definitely, probably, more than likely. It doesn't sound right, but you know what I'm saying. But you'll probably have a likelihood of seeing on the test that you're not going to find in the test preparation books. So let's just jump right in. And I thought this was a pretty cool picture. But physics for military aptitude testing. Okay. Just give me 1 second here to get myself acclimated. We can jump right in. Okay, physics deals with quantities that can be measured. Everything can be measured in pretty much 4 basic dimensions. Mass, the size of volume of something, length, time, and electrical charge. And keeping all these in mind, we're going to always think in these 4 realms of things: mass, length, time, and electrical charge. So keeping that in mind, the first thing that we're going to talk about is speed. And in this video, we're going to talk about speed, and we're going to talk about velocity. We're going to define them. We're going to cover some examples that you may find on the test, and definitions. Speed. Speed can be defined as the distance traveled divided by the time of travel. So, in a nutshell, like one question that you may get is something like this: if you travel 1,200 miles in 2 hours, the average speed that you will find that you're traveling at is 600 miles per hour. What I've done is I've pulled up the formula, and we have a little short video inside a video. Speed can be defined as the distance traveled divided by the time of travel. So let's see here. In our example here, if you travel 1,200 miles in 2 hours, the average speed is how many miles per hour? So that comes from our distance equals rate times time formula. And if we're going to divide speed, or the rate, then like we said, speed equals distance traveled divided by the amount of time traveled. So time multiplied by speed equals distance, or if we have this factor, which is the 1,200 miles, and we did that in 2 hours, then we could divide 1,200 by 2, and we basically get 600. So 600 miles per hour is our answer here. Okay, so we executed that problem, and we have our speed formula, which is speed equals distance divided by time. Another question, and it won't specifically be these questions, but the basic information in the questions are going to be asking you for certain things like defining speed or defining distance or defining time. So if a cheetah runs for 15 minutes at a speed of 80 miles per hour, and I got a little typo in there, let's make a little adjustment. Miles per hour, what distance does it cover? And we have a video for that as well. 15, okay. Alright, so for this example, if a cheetah runs for 15 minutes at a speed of 80 miles per hour, what distance does it cover? Now, cheetah probably wouldn't be running that long, but for our purposes, as far as the question and calculation goes, we come back to find out, we want to know what distance does it cover, so we're solving for distance. So the speed is going to be 80 miles per hour in the equation, and then we said 15 minutes. 15 minutes. Now, we cannot use 15 minutes. What we have to do is we have to convert this to decimal form. So, right here on the side, we will convert 1 hour to decimal form would be 1. 45 minutes in decimal form would be 0.75. 30 minutes in decimal form would be 0.5. And 15 minutes in decimal form will be 0.25. So we multiply, this would be 0.25 in decimal form because it is 25% or 1/4 of an hour. So for rapid math purposes, what I would do is I would just, instead of saying, okay, what is 25 or 0.25 times 80, what I would do is just multiply 25 times 8, and we'll add 0 later. So we have 40, 16, 2, 0. We have to add 0 back. And we have to remember we had 2 decimal places that we have to bring it in. So our final answer is 20 miles. 20 miles. That is how much distance the cheetah has covered. Okay, so we answered that. The cheetah runs 10, 15. That's pretty cool. I can just make my little adjustments here. Runs for 15 minutes at a speed of 80 miles per hour. What is the distance it covers? Plural. S. Okay, and the answer is 20 miles. Alrighty. One second. Okay, so moving right along. Here's another question. What is the average speed of a vehicle that covers 250 miles in 2.5 hours? And you can pause right here if you want to calculate it on your own, but if not, I have the calculation here. 250 miles in 2.5 hours. So 250 miles in time, 2.5 hours. So 250, and we're trying to calculate speed is the unknown in this equation. 2.5 hours. All right, so we take 250 and 2.5 hours. Now the decimal comes over one place, so we're going to add a 0, place a decimal, and 25 goes into 25. 1, 5, 0, and we have to bring our zeros over. So this vehicle is traveling at 100 miles per hour. 100 miles per hour is our answer. Okay, so this was the answer to our previous question. Speed equals distance divided by time, and you can go back to the video previously if you want to solve for distance or time after speed. Now, in physics, we use meters, and I'll just make an adjustment here. We use meters as a basic unit of length. So, in this question, if you walk at a rate of 4 meters per second, how far do you walk in 12 seconds? And again, we are going to go ahead and set up this problem and execute it. If you walk a rate of 4 meters per second, so our rate or speed is 4 meters per second, m/s. 4 meters per second. The question is asking us how far do you walk in 12 seconds? So we have time. We're looking for distance, that is the unknown. The time is 12 seconds. Well, at 4 meters per second, and that means every second we're going to move 4 meters. So if we go for 12 seconds, what we have to do in order to find the distance covered, we need to multiply 12 times 4, and we will get 48 meters. Okay, so that's how much distance we would travel if a person's walking at 4 meters per second for 12 seconds of elapsed time. Okay, and again, we have answered that question and executed it. 48 meters is our answer. Now, the next thing that we're going to get into is acceleration. Acceleration. What is acceleration? Well, let's just take this aircraft in mind. It is actually shot off of the carrier via with the use of a catapult. And as this aircraft is launched off the catapult, we say that it accelerates. Okay, so it starts at a 0 or at rest speed of 0 meters per second or 0 miles per hour, and then all of a sudden it goes to probably maybe 180 to 200 miles per hour. Okay, so we had a little slight interruption there, no problem, no worries. Alright, so we said that this aircraft accelerates because it goes from a point of rest to a point of probably a couple hundred miles per hour as it is launched off the catapult. So acceleration can be defined as the change in speed divided by the time it takes to make the change. And here is the acceleration formula. A represents acceleration. V1 represents, I guess, the speed at a given time, and V sub 0, and these would be small, but for some reason the program wouldn't let me make them in subscript, and that's alright, as long as we know what we're dealing with. So V1 and V0 is the velocity or speed portion of the formula, and this is divided by time to understand how much we have accelerated. Or if we have negative numbers here, decelerated. So we just talked about that. VO, that's the start speed. V1 is the speed after a certain amount of time has elapsed or passed. So normally we refer to acceleration as a gain in speed. And like we talked about it, when this top number becomes negative, like let's say our start speed was 50 and then our finish speed was 30 or 0, then we would have a negative number up top. And so this negative acceleration is called deceleration. So our little questionnaire is asking us what part of the acceleration represents a change in speed, and that will be the top. And again, if the top number is positive, that is acceleration. If it winds up being negative, then it's deceleration, and then divided by time will give us the our what am I looking for? Our deceleration there. Okay, so finally, acceleration. Okay, so in this case, a truck takes 5 seconds to increase from 30 miles per hour, so it's already in motion, to 50 miles per hour. What is the truck's acceleration? Give the answer in miles per hour per second. Now don't let that throw you off. That's what our acceleration, because of the elapsed time, the basic units are miles per hour. And since we're using 5 seconds, that's what the acceleration is going to be in miles per hour per second. I know you guys normally use 2 miles per hour, knots per hour, meters per second, but this answer is going to give us miles per hour per second. And I went a little bit too far in the slides, but no worries, we'll go ahead. I'll just put ACC. That is the acceleration formula. And the acceleration formula is V1 minus V sub 0 over time. Alright. So this represents the change in speed. The time it makes over the time that the change happens. So just to jump right in, let's talk about one of our examples that we're going to cover earlier, or not later. I mean later in this video. In this section, let's talk about a truck. It takes 5 seconds to increase from 30 miles per hour to 50 miles per hour. So 5 seconds. And notice it's kind of just like the distance rate and time, so to speak. So 5 seconds to go from, and this VO is V sub 0 is the start speed or the initial speed, and V1 is the final speed. So that is 50 minus 30 over 5. And our acceleration is going to be miles per hour per second. Don't let that throw you off. Just let that soak in for a minute, and we'll address that later. But 50 minus 30 is 20. 0 over 5, and that is going to equal 4. So the acceleration is 4 miles per hour per second. That is our acceleration rate. Now, 50 minus 30 is equal to 20, which is a positive number. If we came up with a negative number, then that would be deceleration. Alright, so very, very important to get that. Alright, because then we would have a deceleration rate in miles per hour per second. Okay, so that concludes the end of our little video here. I tried to keep this around 20 minutes, so it's not too much information. I'm going to try to keep these small because there is a lot of information that you need to swallow or take in, and so I rather do it in nice little clips and not too long. I don't want the video to be too long. So we talked about speed. Speed is distance divided by time. Alright, distance traveled by time of travel. And acceleration is your final speed minus the initial speed over time. And so we talked about speed and acceleration in this video. Again, this is information that you're not going to find on the military aptitude tests in the area of mechanical comprehension. And that's for the Sift, that's for the Astb-E, it's for the Afoqt, and the Asvab. All of them. They're all leaning towards physics. You more than likely will not find this information in, I haven't seen them in the test prep books at all. I'm a Barnes & Noble freak, like I said, and I'm always looking through these books and just seeing what my competitors are doing. And my competitors do not have this information in their books. So this is going to be a really, really cool series, and it's going to give you guys a lot of good information. And I encourage you to like, subscribe, and share on your social media networks. And the next thing we're going to talk about is we're going to get into gravitational pull and things of that nature. But again, I thank you guys for taking time out to watch my videos. I thank you guys for subscribing. It really, really means a lot to me. I don't have 17, millions of subscribers like most people, but I do appreciate the guys that do subscribe to me and watch my videos. I thank you guys again for watching, and have a great day. This is Kieno Thomas with Kieno Training Systems. Have a great evening.